because you can create a require function, but you cannot create an export keyword. So this time we need to go a little bit deeper than with the CommonJS module format, because to actually be able to bundle this code, first we could do, for example, an idea could be that we get the ES6 modules and we convert them to CommonJS format, and then we can apply our previous implementation. So we convert, because we already know how to bundle the CommonJS modules. And this is actually what Browserify and Webpack did, or actually not Webpack 2, but Webpack 1 did, because when the ES6 module format came out, the bundlers didn't have time to do the actual implementation of supporting the ES6 modules. So what they did, they suggested you to use, for example, Babel, and convert your ES6 modules to CommonJS modules, and then they could do the bundling. So we will see how we can actually convert the ES6 modules to CommonJS format. So the question is how to modify JavaScript source code and do this conversion. And actually there is already a solution for that. It's called, or the concept is called the abstract syntax tree, which is a tree that represents the syntactical structure of this source code. And it's always a result of syntax analysis, so some kind of parsing. This might sound a bit abstract, but we will see on an example. Just in JavaScript, there is a common specification for abstract syntax trees. It's called the ES3 specification, and there are many compatible parsers. For example, Acorn, which is used by Webpack, rollup, and Browserify. So all the bundlers are relying on this parser. There is, for example, ES Prima. I'm not sure how to pronounce it, to be honest, but it was implemented by jQuery, and for example, Istanbul, the code coverage tool is using that one. And of course, there is Babylon, which was created by Babel, and it's their own parser. But how does actually the EST look on an example? So we have this code. The first line is an import statement. If we parse this code, this will look something like this. So you can see that from that one line of code, we get an object that describes what it actually is, and like that, it's easy to know that, for example, the type of this node is an import declaration, and it has a child node, which is an import namespace specifier, and here it will say that the name is calculator, and here it will say that the value that, or the name of the module is ./calculator. So like that, it's much easier to do any transformations on the code, because you don't need to deal with regular expressions or something similar. You can just do transformations on objects, and we all know how to do that. There's a really cool website, which is the EST Explorer, where you can actually, it's very similar to the TypeScript playground. You just type in some code, and you will see how the abstract syntax tree looks like. So if you are curious, I recommend you to check out and play with it. And if
sorry, so basically this structure on the right is created by some parser, right?
Exactly. So if we go back, this is the specification. It will describe you that import statement has a type of import declaration, and it's like the ECMAScript. So it tells you how the language looks like, and these are the parsers, like the browsers. So the browsers are implementing ECMAScript, and that is the JavaScript. So here it's very similar. So these are the parsers that can understand the code. and provide you with a syntax tree. And if we check this source code, what it does, it will convert all the import statements. Maybe it's better like that. It will if you pass in this code where you have an import statement, this will convert it to a CommonJS format. And it's relatively simple. What here, maybe it's not readable. What we do here, we just require acorn, which is the JavaScript parser, and we call acorn.parse, and we pass in the string that represents our code. So we pass in that as a string. And we specify some options. For example, that this is a module, the ECMAScript version, which is here 2017, but it could be 2015 because we don't use any features from 2016 or 17. And so this is the first step. Here we have the syntax tree. Now the second step, instead of starting to iterate through the syntax tree by our own, we will use a utility library which is called ES_traverse, and it has many nice methods that help you modify the syntax tree. For example, it has a replace method. So you can just say that I have an abstract syntax tree and I want to replace, and you pass in an object and you can say that whenever the type of the node is an import declaration, I want to replace it with this node that I return here. And here what we do, we just create a string, and from the node we put here the name of the import, and here we put the value of the import declaration, which is the /calculator. But this is a string, so we need to call acorn.parse again, so that we have a node that we return instead of the original node. Like that, we modified the syntax tree. Now the next step that we need to do is to convert it back to a string. And there is, for example, the ES_gen library that if you pass into the generate method a syntax tree, it will just return you the string. So it will convert it back to actual JavaScript code. And that's more or less it. So like that, we can convert the import and export statements to the CommonJS format. And once we did that, we can just use our previous bundler and do the bundling on that. Was that understandable? Awesome. And yes, so this is how we could do that, but ES6 modules without using Babel or TypeScript, you can bundle it with Webpack 2 and with rollup.js. And this is what we will look into in the next part, how actually rollup.js does the ES6 bundling. So without this extra transformation from the ES6 module format to CommonJS, it works directly on export and import statement, and we will see how it does.
So internally, this bundler, the new versions, they don't do a step of transformations. They work directly on the import and exports.
Yes, but it's important to mention that they will only transform the import and export statement. So if you write ES6 code and use, for example, the arrow functions, for example, or destructuring or something, it won't touch that code. So that will be present in the bundle the same way as it is in your original source.
Using the separate transformation for them.
Yes, exactly. So they will only transform the export and import statements. And actually that is why if you check the TypeScript compiler, it has two options. You can specify the target, so the ECMAScript version for TypeScript that you want to build your TypeScript code to, for example, ES5 or ES3. And then it will transform, for example, the arrow functions to actual functions. And you can specify separately which module format you want to transform. And and with Webpack 2 and with rollup, it's better to leave it as ES6. So TypeScript will transform everything to ES5 apart from the modules. The modules will stay exports and imports, and then rollup or Webpack will transform that. Because if you, for example, if you use TypeScript and you transform it to AMD or CommonJS format, then you will lose the advantages of the ES6 modules once you run the bundler. So it won't be able to do the tree shaking because you pass in the CommonJS format, for example. Then that's important to mention. Yeah, so are there any more questions related to this or? No, okay. So before we actually do look how rollup.js works step by step, let's do an output comparison because I think it's very useful to see that this is more or less the browserify code from that one. So if we use our first, if we transform this to CommonJS format and then apply our bundler, this will be the output. So that is actually the same code that you've seen a couple of slides before, just we had on the left this part where the modules were, and this is the bootstrap function that were on the right side. And so it's nothing new. I just wanted to show that this is the size that browserify will result in. With Webpack, with the optimization step that we remove basically the optimization was just to recap that here instead of /calculator and specifying the dependencies, the Webpack-like bundler will require the modules directly by its ID, and that's why it's smaller. But if you check what rollup generates from this code, it's this. So I think it's really interesting that just by the output you can tell that it's a completely different approach. What you can see here, there are no modules. So with Webpack and with browserify we still had the module-like structure in the final bundle. But with rollup you don't have it anymore. It will put everything in the same scope. So it is more or less the same code that we had on the very first slide where I said that it's a spaghetti code. So what we can say for rollup is that we kind of used to look a code like this on the front end, which means that it's a very readable output. And just by the size you can say that it's quite efficient because it doesn't have so much boilerplate in the generated code, and actually we checked. Actually, Michael checked. He did some measurements on the generated bundles generated by Webpack and rollup, and just by using rollup instead of Webpack, we could see that on the front end we gained around 8 or 9% in the bundle size, just because it has less boilerplate in it. It will remove all the modules, module code actually, and that's why it's also faster to execute because there aren't so many extra lookups between modules, but that's not that significant. So I think it's quite interesting to see how actually rollup does it. So how can you transform that code into this one? Because it's not just transforming the export and import statements. And
sorry, Peter, one question. I guess it avoids name collisions. If
we will talk about that, but that's a very good question because, as Pietro pointed it out, if you have two modules that has the same name in it, since everything will be put in the same scope, we will have name collisions, and we somehow need to resolve those. But we will see that. Thanks. It's not that intimidating as it might look for the first. This is actually how rollup.js was built internally. So this is the class diagram of rollup.js. Basically, they are using an object-oriented approach where they have a bundle class. And the bundle class has many modules. The module class has many nodes, and the nodes are actually the abstract syntax tree nodes, what we have seen before. For example, import declaration, export name declaration, or an if statement, or a function call, or a return statement. And the module has a module scope, and the bundle has a bundle scope. So if we look at this code, let's try to match these classes in this code. Before we do that, we can see here that our calculator module got a bit smarter. It can multiply now. But in the index.js, we won't use that feature. So we would expect that won't be part of the final bundle. So let's see how it goes. So what rollup will do when you start the bundling? First, it will create a bundle that represents the final bundle, and it will create a bundle scope in it. We have seen that in the final output we have just one scope, so the bundle has one bundle scope. So far it's okay. And then it will start from the entry module. It will create the classes or the instances for all the